Okay, welcome back to our statistics class notes. We are on page 92, and just a bit of notation here at the top of the page. In general, we use Greek characters to represent population parameters. So for example, a population mean is represented by the symbol mu, which you saw last chapter when we were talking about the normal distribution. Population standard deviation is represented by sigma, again, which you saw in chapter 6, talking about the normal probability distribution. Population variance is simply standard deviation squared, so that's sigma squared, and population proportion, we're going to use the letter P, and that's what this chapter is about, looking to try to make inferences about population proportions with, on this side of the chart here, the sample proportion, which we label P hat. Other sample statistics could be the sample mean, which we've seen before as X bar, the sample standard deviation S, and the sample variance, which we won't use much again, but it's S squared. It's simply the standard deviation squared. Okay, example 121. Suppose the mean GPA of all 2,500 students at Flagler College is 3.03. A sample of 75 GPAs from this school has a mean of 2.97. So the population that we're looking at is all Flagler College students. The sample is the 75 whose information on their GPA was then collected. Now the parameter, which is the population mean GPA or population mean, mu, is 3.03. And the statistic that we could use to try to estimate that if we didn't know the population parameter mu, but since we know it, that's fine. But the value of the statistic that we would have used to estimate that mean GPA of all Flagler College students comes from our sample. And that's the sample mean X bar, which is 2.97. And you can see that if we hadn't known the 3.03, that we would have been off by a little bit. So there's always going to be some uncertainty in our statistics. Okay, before I go further, I want to talk about bias. What is bias? Bias is a survey method. A survey method which is biased is because it has a tendency to produce an untrue value. Now, there are three types of bias that we need to investigate, and we'll try to eliminate. They are measurement bias, sampling bias, and then the use of an estimator that is biased. Now, the use of an estimator that is biased is kind of beyond the scope of this course. I simply need you to kind of push the I believe button at this point that when we use an estimator, now remember the words where estimator is just another word for statistic. So when we find P hat, a sample proportion, or we find X bar, a sample mean, there's a lot of mathematics behind this, but they are proven to be unbiased estimators. They have no bias in them. So we do not need to look at whether the estimator is biased. But we do need to have a better understanding of measurement bias and sampling bias. So what is measurement bias? Measurement bias results from asking questions that do not produce a true answer. It occurs when measurements tend to record values larger or smaller than the true value. Now, sources of measurement bias can occur in a variety of situations, including self-reporting of personal data. I always give the example that if somebody wanted me to report my own weight, it probably isn't going to be true. I always give about 20 pounds lighter than I actually am. Just wish. But anyways, the use of confusing wording in survey questions. The use of non-neutral language in survey questions. Language that might lead survey respondents to produce a certain answer, which is not what we're supposed to do in surveys. Okay, so those are all measurements. Sampling bias, by the way, just means bad samples. So think sampling bias, the sample's bad, it doesn't represent the population. Measurement bias, we have bad questions that don't produce a true answer.